Welcome to a new video in my home automation series, and today I'm going to talk about my first ESPHome sensor or the ESPHome board. So I'm going to explain how that works and how you can build it using the board that I have designed, and also, well, how you can use it with ESPHome. And just to talk about the board a little bit, it's, well, as you can see, it is designed, powered by an VMOS D1 Mini, so an ESP8266. And for this one, I just used two sensors. So here I have a BME680, so that measures temperature, humidity, and pressure. And I have this radar sensor just above that. So I'm using the I2C pins from the board, and I'm using this board which is down here, that's for this radar sensor. So obviously the BME uses I2C, so I'm reading the data there, and of course I have included footprint for other sensors. So if you want to use multiple I2C sensors, then what you can do is just the way that I raised this board on a longer standoff. Maybe you can use a longer standoff for the BME280, and then you can fit another sensor below it. And of course, you also have the option to fit it on the other side as well. And I've included a footprint for a couple of different sensors, but I mean, these are just, holes for, pins for 3.3 volts ground, SDA, and SCL. So as long as you have any sensor which is supported by ESP-Easy and uses I2C in the same pinout, of course you can use that. So it's not limited to these three sensors that I have in mind. And also this radar sensor, I mean, I'm still playing around with it, I've read that, well, I've got some comments that it has their own issues, it's too sensitive, so it might not be suitable for everyone, but it is just basically connected to the input pin of the ESP-Easy. I don't remember which one it is. We are going to see the code. So if you prefer a typical PIR sensor, you can use that as well. You just have to, make sure that you are using the pins that are compatible with the with this infrared sensor. And by the way, I'm going to include the links and the schematics, so you will be able to find which one is connected to the ESP and which one is ground and power. This actually gets 5 volts. And I'm not using any of the other pins for this particular project, and this is why I'm going to make several of these videos, because each of the sensors are going to be slightly different, so you get to see how I'm using some of the other layouts in the board. But I did cover that in a separate video. And this one is going to be mains powered, so I'm using my trusty High-Link 5 volt power supply, and I've installed a MOV or a Varistor as well, and there is an inline fuse. So if you don't want to use the Varistor, you can just not populate it, and then if you don't want to use a fuse, you can just use a wire to connect the two fuse terminals, and then it's going to work. But since mine is going to be in the holiday home, when sometimes we have issues with lightnings, and so that's why I included the Varistor, and the fuse is just general protection. It's not a resettable fuse, so if it blows, then well, this unit is not going to work until I replace it. Just to recap on some of the past videos, in case you are not a subscriber, I've done a separate video on the actual board where I explained a lot on how I designed it and what different purposes I designed this board for. And in this video, I'm going to talk about how I'm going to use ESPHome to set this board up, how to build the firmware for it, and I'm going to use ESPHome without Home Assistant. So I've again done a video on how you can set up ESPHome and how you use it without Home Assistant. If you are using Home Assistant, then using ESPHome is probably even easier, because there is a nice ESPHome interface integrated into Home Assistant. Let me switch screens now, and I just want to show you a couple of things that I have included in the project, or a couple of links that you can watch. I mean, first of all, as I said, the PCB is made by PCBWay. So if you want to, run your own boards, then you can just talk to them. And the reason I like PCBWay, I mean, this could be the true for other PCB manufacturers. They also have this project page where I can create a project on my design, and basically you come here. You first you see some documentation here as well, so you can see what sensor the board supports, or the things that I had in mind when I designed it, and also included links wherever I purchased these sensors from AliExpress. So you can get those. By the way, there is a schematic is also available here, so you can see how each pin is connected to the ESP. And if you want to order the board, you can just click here, add to cart, and you can just order the very same board, and you can build the same stuff. And anything that I'm going to talk about ESPHome related, I'm going to upload to this GitHub repository. It's not a code, but I'm just using GitHub to share data, mostly because I can also include some documentation to go along with it. So you're going to see that I've already included the 2 videos that I talked about, and the link to the PCBWay project, and of course, yeah, all going to be in the video description. So this was all the getting started bits. So what I'm going to do now is I'm going to plug in this board to the mains, and I should remember not to touch it because the top part of this PCB is live now, and I just need to check whether this is on. Yeah, it is on. So now what we can do is we can go through the actual ESPHome file that I created for that. First of all, I'm going to use the name of the device in a couple of places. So I created this substitution where it has a variable basically, which is the device name. So this is living room, and as you can see, I'm using the device name as to name my ESPHome project, and a couple of things later as well. So I defined that the platform is A266 and the platform is D1 Mini. I've included the OTA password, and as you can see, most of the password related stuff is stored in a secret file. So there is a secrets.yaml where I defined those basically secrets that I'm going to use. All you need to do is you just have to make sure that the secrets.yaml is in the same directory where your the main YAML file is. So I have a password for the OTA. I have the Wi-Fi details, the SSID, and the password. There is also like a fallback access point, and that's the main declaration that you need. And normally there is an API declaration as well, but that is required for Home Assistant, but that is not required for my case because I'm going to use MQTT to communicate with Node-RED, so I've removed that. But if you want to use Home Assistant, you need to put that one back. Next, I configured the MQTT part, so there is a broker username, password, and the client ID, which is the same as the device name. So that's fairly standard stuff. This is what you need to get MQTT enabled in ESPHome. Again, for Node, from Home Assistant, you would remove this entire section. And with this, we already come to the configuration of this typical board. And the first one is, because we are going to use I2C, we need to define the I2C. So on the ESP8266, the SDA and the SCL pins are 4 and 5, and that's what you need. And I think I'm going to skip some of the parts. Let me just go directly to the sensor. So here I'm using a BME. Oh, I'm actually using a BME680. I think I said 280, but I'm using the 680 because I wanted to measure. I want to measure gas resistance, which is the this VOC value, and I want to see how that relates to the quality of air. If I can draw a conclusion from the VAC value in order to tell if the, let's say, if the air is moldy or used, because this is what I will try to base the ventilation on. If I need to circulate the air, I mean, probably the humidity and the gas resistance is going to give me some indication that I need to do something. But going back to the actual configuration of the sensor, so we have a sensor section in the YAML, and then platform BME680, which gives you these 4 values. So you have temperature, pressure, humidity, and gas resistance. And normally this is all you need to provide this tag, the name and the oversampling. And I also added a state underscore topic for each of them because I wanted to default the MQTT topic. If you don't provide this, then ESPHome is going to default some MQTT topic, which is going to be like sensor slash something else. I mean, I don't remember, but it's a much longer topic, and I just wanted to keep it simple. So if we look at the MQTT traffic living room, well, it's definitely working. So you can see temperature, pressure, humidity, and the VOC. So these are these values, and as you can see, it is on the living room, which is the device name. So that's all it takes to set up the BME sensor. And the next one is, let me go up and talk about this one, is for each of my project, I like to include the Wi-Fi RSSI because it just gives me an indication of the location of the device. I mean, if it starts to go below -80, that means that it's just too far away from the router and probably becomes well, could be unresponsive. So I mean, -60, 50 something, I know that it has a good enough reception. So this is all it does. It just reports the Wi-Fi signal every minute. And by the way, yeah, the update interval for the BME680 is also every minute, but probably you can get it down to every second if you want to. The other thing I usually include in my project, which is not, I mean, again, it's not really required, is the uptime calculation. So that is also a value. So you have uptime, you have to define like this. And I also supplied an MQTT topic that updates every second as well. And I have also included these 3 lines here, which is a lambda function where I divide the value by 60 because by default the uptime sensor provides the uptime in seconds and I just want it in minutes. So I divide it by 60 and the unit of measure becomes m as minute, and as you can see it's 3 minutes. So I connected it, well, 2 minutes 57 seconds ago, well, technically 3 minutes. And this section here is responsible for generating this sort of human readable uptime, where it's going to say, days and hours and minutes and seconds. So again, this is a lambda function which just, does the conversion from the seconds into, the various part. And as you can see, it updates the text underscore sensor ID or device. I'm not sure how it's called, which is configured here. So as you can see, text sensor. So this is the human readable text, uptime text. So uptime text here, which is being updated by this code. So that's about uptime, maybe a little bit too much, especially if you don't need that. And finally, we have, as I said, 2 devices connected, the BME680 and this radar sensor, which is basically just a binary sensor. So this doesn't give you anything. It has an output pin, which it pulls high or low, depending on whether motion is detected or not. This is why I said you could replace it with a PIR sensor if you want to use that as well. And it is connected to D6 pin of the ESP. And I called it the radar sensor. Actually, I should have included a mark here. Yeah, okay. And it has a device class motion, and that's the topic. So I'm getting this either on and off based on whether motion is detected or not. So that's all there is to it. And the only other thing I've included is this port here. So web server port, because I like to have my devices, I like to include a simple web server on all my devices. And as you can see, once you add these 2 lines here, and then once you open the IP of your ESP, then this page is going to be provided. I mean, it doesn't do much. It just gives you all the sensors. It updates this table automatically. And also you will be able to see some messages here as well. And that's pretty much it. I mean, the reason I like to do it is because I have a lot of devices at home, and sometimes I don't know which device is which one, especially if I'm just looking at IPs, and I can just quickly copy and paste the IP into a web browser, and I can see that, oh, this is my sensor, that's the IP camera. I mean, most of the devices, okay, not most, but yeah, so especially all my custom devices have an IP, a web server, so I can just quickly tell which one they are, you know, from the IP address. But yeah, that's it. I don't think I've made any changes since I last compiled this YAML file, but I'm just going to show you how this is done. So this is the folder where this file is at. So I'm just going to start a command prompt, and I'm going to type ESPHome run livingroom.yaml. And I want to update this device immediately once the new firmware is built. And of course, ESPHome supports over-the-air update. So because it's not connected using USB at the moment, I'm going to use the over-the-air update. And the way I usually do it is I add / device and the IP. 192.168.1.181. And that should work. So now ESPHome is compiling the new firmware, which I think is going to be pretty quick because I don't think there has been many changes since the last one, the last version. Okay, actually it's doing some stuff here. And waiting a little bit more. Okay, this is success. And now it's already uploading to the ESP. Okay, OTA was successful. And yeah, there is no remote debugging enabled. So I can't use remote debugging. But if I just refresh this page, then you can see that the uptime is 0 because it just got restarted. And also you can see in the log that it just got restarted. I think these ping parts are when the device is restarted and it was scanning the I2C bus. So this is all it takes to update the firmware on the sensor. And as you can see, it is not connected anywhere. I mean, of course, it's connected Wi-Fi and the power. So once I have it installed in a final location, I should be able to make changes to the firmware easily using the process that I just shown you. So I think that will be all for today. There will be more of these shorter sensor videos coming as I build some of the other models. If you are interested in this, I'm going to leave all the links in the video description to the pages that I mentioned in the beginning of this video. But I think that will be all for today. Thanks for watching, and hopefully see you in the next video.